Hi, in this video I'll show you guys some more examples on integral of sine and cosine functions. Okay, so I'm gonna go over 3 examples. Okay, so let's get started. What I have here is I need to integrate cosine of 4x minus 6 with respect to x. Right. Okay, so we should be asking ourselves, what do I differentiate? Right. What do I differentiate so that I have a cosine? And that's going to help me to find the integral. Okay, so when I differentiate sine x, I'll get cosine, right? When I differentiate sine x, so that's what I'm going to start with. When I differentiate sine x, I'll get cosine. So if I differentiate sine of 4x minus 6, when I differentiate 4x minus 6, I'll get cosine of 4x minus 6. However, remember, technically, when I differentiate this trig function, there is a linear function in a trig function. Right? There's a linear function in a trig function, so we have to apply. What do we have to apply? I hope your answer is chain rule. Right? Chain rule. So if I just differentiate sine of 4x minus 6, I do get the cosine of 4x minus 6, but at the same time I need to differentiate the linear part as well, right? Which gives me, if I differentiate, okay, so let's do this. On the side, I'm going to differentiate sine of 4x minus 6, right? 4x minus 6. So I'm doing this with the mouse. I apologize for the bad handwriting, but I hope you guys understand what I'm writing here. Okay, so like I said, when I differentiate sine of 4x minus 6, I will get cosine of 4x minus 6. But that's not it, right? This is cosine of 4x minus 6. I also have to worry about the linear function. This part, right? This part is a linear function, so which gives me, if I differentiate 4x minus 6, I hope your differentiation scale is good. So if I differentiate 4x minus 6, I just get 4. Right? So this is multiply. This is multiply 4, which gives me 4. And I'm just going to copy and paste this. 4 of that. Okay. However, what I'm trying to find here is something. When I differentiate that something, I'll get just only 4x minus 6, right? Just cosine of 4x minus 6. So what I have here is gives me something that's very close to what I want, but I have this extra 4 here, right? So for me to deal with that, I just put a 1 over 4 in the front. Alright, so this 1 over 4 here will take care of this extra 4 when I differentiate the sine of 4x minus 6. Alright, and don't forget the plus c at the back, right? The plus c at the back. Alright, let's look at another example. Okay, so here we are going to integrate a complex function where we have exponential and also trig, and inside the trig we have exponential as well. Alright, so it looks very complicated, but it's actually not that bad. So let's think about, what do I differentiate that gives me a sine function. I hope your response is cosine, right? So when I differentiate cosine, I'll get sine. In fact, if I differentiate cosine of ex, I'll get sine of ex, but not just sine of ex though, right? Now, when I differentiate cosine of ex, so let's see what we get if I differentiate cosine of ex. Okay, cosine of ex with respect to x, that gives me, so when I differentiate cosine, I actually get negative sign. right? Negative sign. So, which means I should have a negative in the front, right? So that will take care of business. Okay, and then whatever's inside, we'll leave it there, right? Now, this is a exponential function in a trig function, right? So we need to apply chain rule again, right? So what we did here is we only took care of the trig function itself, right? So we need to worry about the exponential function as well. Okay, so if I differentiate ex, I'll just get ex. So let's write this: negative ex sine of ex. Right? Okay, so if I just differentiate cosine of ex, I'll get that, right? That's why I put the negative in the front. The negative here will cancel with the negative there, right? So which gives me a positive, right? But not only that, and that's it. Actually, that's it, right? Because this ex here, this part will give us what we want here. Oh, sorry. Let me change the color. This part, right? And this part will give us this part, and the negative and this negative will cancel out. So that's it. My final answer is negative cosine of ex. Alright, let's look at the last example. Okay, now let's see what we got here. So we are going to integrate a cubic function and a trig function and some polynomial within the trig function. Okay. So again, what do I differentiate so that I get cosine, right? So I hope your answer is sine. So I have sine, and then sine of. So in order for me to get cosine of 3x to the power 4, when I differentiate sine of 3x to the power 4, I'll get this part, right? I'll get this part. However, we have a polynomial. This part is a polynomial in a trig function. So when I differentiate sine of 3x to the power 4, with respect to x, I will get the cosine of 3x plus 3x to the power 4 that I wanted. 3x to the power 4. Right? I'll get that. But not only that, I'll also get something else. Right? I also get the derivative of the polynomial, which is 12x cubed. So I'm applying chain rule here. Right? 12x cubed. Alright, however, what we are looking for right now, so if I rewrite this, let me just clean this up a little bit. I have 12x cubed cosine of 3x to the power 4. Right? So when I differentiate sine of 3x to the power 4, I get this whole chunk, right? Which is very, very similar to what we have here. Very similar, except what? Except the 12 over here, right? Except the 12. So I have the x cubed here, the x cubed is here, right? I have the cosine of 3x to the power 4. I have the cosine of 3x to the power 4, right? But I do not want this 12, so I can take care of it by just putting a 1 over 12 in the front. Right, so the 1 over 12 over here will deal with this 12 right there, and they'll just cancel out each other, gives us 1. Right? And don't forget the plus c at the back. Okay, this 3 examples, feel free to replay and try to do this on your own. Right? Even though I've shown you guys how to do this, it still helps. You know, just kind of do this on a piece of paper, and see if you get what I have here. Alright? Okay, good luck. I'll see you guys in class. Bye.